All right, good evening, everyone, and welcome to the June meeting of the Ottawa Centre of the RASC. Okay, so let's get going. We've got a pretty full program today. It looks a bit stacked to the front half, but that's because some of the talks at the front half aren't particularly long. But we've got myself, just with the introductions I just did. I'll be presenting the skies for June. Unfortunately, Dave Chisholm can't make it, so I put my hand up and said I'd do it. So he's provided the slides, and I'll just go through them. We've got Al Scott with his 10-minute astronomy news update. Just to make sure, Al, are you here? Oh, good. We have Gordon Webster talking about the Parliament Hill Transit event, or as I like to call it, we saw a dot. And then Brian McCullough with a recap of the GA in the 2016 GA in London that happened just a few weeks back. He'll keep us up to date on any new developments. Then we have the break. Then we have Chuck O'Dale giving us another installation in his, I guess, ongoing series of talks entitled tentatively, or perhaps just colloquially, Big Holes in the Ground, or really big holes in the ground. We then have the observations, the announcements, and then the door prizes. So we'll just, I guess, kick right off. Oh, sorry. Welcome to our new members. As you can see, we have 5 new members who joined in the last month. Welcome. And like I say every month, I hope you find this organization as enjoying and as interesting as I have over the last many years. Oh, and if you, I just noticed the little line on the bottom. If you are looking for a membership card, they're available from Art Fraser in the theater foyer after the meeting or perhaps during the break. Members in the news. We have, despite what it says down here, it should be Stephen McIntyre, and this photo was uploaded onto the CBC. CBC Ottawa, and as you can sorry, okay. Doesn't look like the green laser pointer is working very well. But there it is. That's the dot. That's the dot we saw. So thank you very much. Well done, Stephen, to get your... well done to get your picture onto the CBC, despite them misspelling your name. Here we have Mark Slatter. This was in the Ottawa Citizen, page A4. So well done, Mr. Slatter. Obviously, the Hill event was a lot of great exposure for us. And for those who were there, I mean, it started out looking, the morning started gloriously. Then the clouds rolled in and we thought, oh no, here we go. And then, of course, just as the minister comes out, skies open up, and we've got beautiful, beautiful, nice, bright sun.
She has connections.
Yeah.
Sunny ways, Gordon, sunny ways.
You know what? I'm trying to think of a retort to that, and I just can't. So, well, they came out. Well, the clouds parted just in time. Yeah, I'm not proud of that one. Trudeau. Trying to work Trudeau in there somehow. It's not working. Anyway, let's move on. We have in Sky News. This is a picture from Shane Finnegan, that made it into Sky News. Again, I don't think he knew until somebody told him that his image had actually been selected in Sky News. They'd seen it. So well done, Shane. As you can see, there's a lot of detail. And there is Mercury, the black dot. I feel I should know, but these aren't exactly sunspots, but what are they?
Filaments.
Filaments? They're called filaments? Okay. Same basic principle as sunspots? No. Magnetic?
They're prominent, seen from the top.
Oh, that's pretty cool. Well done. Yeah, and look at, you got some good prominence activity here and here. Well done. All right, so we'll go into the Ottawa skies for June. As I said, Dave isn't able to be here today, but he did.
We are on the air.
Oh, thank you. Welcome to those who are just joining us live. Again, apologies, you've missed the first couple of minutes. We've been having some technical difficulties, but thank you for joining us. So on to Dave Chisholm's Ottawa skies for June 2016. As you can see, these are the phases of the moon. The full moon is, this month is on the 20th, so a solstice, basically a solstice full moon. Today, the third in the top right, as you can see, it's a new crescent. So, oh, sorry, it's a waning crescent. New moon is on the 5th. Mercury is visible in the early morning, and its greatest western elongation is on June 5th. Venus is not visible in the night sky. Mars is visible all month, so that's rather nice. Jupiter is visible all month in the early evening, or in the first half of the evening. Saturn visible all month again, and it's at opposition on June 3rd, so tonight. So if you're interested, it should make some good viewing. Uranus can be seen in the early morning, and Neptune as well in the early morning. Oh, and this is the International Space Station fly-past data. The best viewing date will be the 8th of June, and you have the coordinates of where it rises and, I suppose, dims. I don't know if sets is the right word, but because I'm not sure if it does it reflect all the way across the sky, or does it stop part way? Stops part way. Okay, there you go. So you've got the. I guess this is where it would stop, and so it comes in from approximately the northwest and goes down across the sky like that. And here we have the non sequitur for the comic, the cartoon of the month, I guess you'd call it. So just read that part. It says, "Buy low, sell high, the secret of Stonehenge." Okay, so now, Al, if you want to come down and give us the 10 minutes. 10-minute astronomy news.
Greetings. So for the news item today, I just have one, but it was somewhat in-depth, so I thought I would present it to you. And it's about local supernovae. As we know, supernovae happen in galaxies roughly once every 100 years or so, maybe a little more frequently than that. And because of that, we know the size of the galaxy, and we know how frequently they should happen close by. So we should expect that the solar system would experience a nearby supernova within 100 parsecs every 2 to 4 million years. And that's relatively frequent in geological time. You've also heard perhaps of the kill zone, where supernovae, if they're too close, the radiation from the blast will destroy life. It will ionize the atmosphere, cause major mass extinctions. And people think that if they were within 10 parsecs, this might occur. This should only happen once every few 100 years, 100 million years, not 100 years. Whew. So, for more than half a century, scientists have recognized a couple tantalizing clues that a nearby supernovae did occur and showered the Earth with radiation about 2 million years ago, in fact. The first hint lies deep under the Pacific Ocean, where an isotope of iron, iron-60, which is radioactive, is globally distributed in a thin layer within the crust. Although there may have been some primordial iron in the Earth's core, it has long since gone away, because the half-life of iron-60 is only 2.6 million years. So every 2.6 million years, half of it disappears. So the fact that this was found in the below the crust and in the Pacific Ocean means that something put it there, some radioactive event. And nearby supernovae are the likely culprits. This is where much of the iron is formed in the explosion from supernovae. Iron is blasted out into space and then rains down as dust onto the surroundings and into nebulae, which then can become can become stars and planets. So, There was also additional evidence of this being an interstellar event in that they looked at the Apollo moon rocks to search for this iron isotope and found it embedded in the Apollo moon rocks. So not only is this found in the Pacific Ocean, it's found layering on the moon. Another hint of the possible existence of a supernovae a couple million years ago is called the local bubble. It's a vast peanut-shaped plasma-filled cavity in the local interstellar medium, and the sun is inside this bubble. So the interstellar medium it's vacuum, but there's also dust and gas, and astronomers can measure the densities of these things by looking at the light that goes through it from background stars. And you can measure how much absorption you see from background stars. And what they find is there's a wall of neutral hydrogen that's absorbing light from stars, and then there's this ionized medium nearby. Within, it's about a 300 light year diameter, this bubble, or chimney actually. It's a chimney that actually sprouts up through the disk of the Milky Way. So we're actually living inside what people think is a supernova remnant. Our solar system right now is in this area. So nearby supernovae probably blew this bubble of high pressure, high hot ionized gas out. It can also be detected in X-rays. The hot ionized gas gives off soft X-rays, and astronomers can detect these X-rays from our local interstellar medium. Recently, astronomers also noticed something peculiar in cosmic rays. They can measure the spectrum of energies in cosmic rays. And now one would think that there should be no footprint or no fingerprint of a 2-million-year-old supernovae in cosmic rays because they travel at nearly the speed of light, and the galaxy itself isn't 2 million light years across. So how could we be seeing cosmic rays from a 2-million-year-old local supernova? Well, the fact is, and I didn't really know this until I researched it, is that cosmic rays don't travel straight. They're charged particles traveling near the speed of light. And because the galaxy has magnetic fields randomly oriented, what happens is these things spiral around inside the galaxy and don't necessarily hit anything. And they actually can spiral around for 30 million years before escaping from the galaxy. And so what they found is that the energy spectrum of cosmic rays in our local environment seems to have gotten a kick sometime within the last few million years. So it's not an equilibrium spectrum. Something has deposited a lot of energy in cosmic rays, and people believe that supernovae and the expanding remnant is what accelerates cosmic rays to give them all their energy. So we have all these hints that suggest that there's been a supernovae in our local environment within the last couple million years. Now the local bubble itself, and this is a picture, a model of the local bubble, and the red represents the distribution of iron-60 from the supernovae that formed it. And this is the size it was 2.2 million years ago when they believe these supernovae occurred, or when the iron-60 encountered our solar system and was rained down on the Earth. The local bubble required the energy of 14 to 20 supernovae over the past 13 million years to excavate it from the denser interstellar medium that would have been here. Astronomers combed through Hipparcos data. Hipparcos is a satellite that measures the speed and distance or direction of stars in our local neighborhood. They looked through this catalog to look for an association of low-mass stars between 20 and 30 million years old at about the right distance from us and moving at the right speed and direction to have had their larger members die spectacularly in our neighborhood a couple million years ago. And what the team found was there are two subgroups of co-moving stars now in the Scorpius-Centaurus Stellar Association, or an OB association. The subgroups are called the Lower Centaurus Crew and the Upper Centaurus Lupus subgroup. And this on the bottom here is a color magnitude diagram which basically plots these stars. And through the science of stellar evolution, we can tell, based on where these things cut off, how old the star cluster is. And this is how we date clusters of stars that all formed roughly at the same period. What happens is that the higher mass stars are bluer and brighter, and the lower mass stars are redder and dimmer, and the higher mass ones suddenly go shooting off on this red giant branch and then explode young. So wherever this cutoff is, it tells us roughly the age of the stars. And you can see that these stars that are plotted are somewhere in the order of 20 to 30 million years old, these clusters that they've identified. And this is roughly the right age to have caused the local bubble, to have blown this bubble out of the surrounding, our surroundings when they pass through our neighborhood. This figure here actually plots the outline of the local bubble. The origin here is our solar system. And this plots back the Hipparcos data from now back into the past 30 million years ago. So these star clusters, these subgroups, have moved this direction, and they're still in the local bubble, but they're just exiting it. And 15 million or 2 million years ago, they were close to the sun, and they may have been the cause of the iron 60. So what the astronomers did was they plotted these things. They sent out a team and they researched the iron 60 in the oceans, and they mapped the global extent of this layer, and they dated the sediments to get a more precise idea of when the supernovas occurred. And what they found is that there were two periods, roughly 1.5 to 3.2 million years ago and 6.5 to 8.7 million years ago, where iron 60 flux was higher. So what's happened is that these supernovae put out a shell of this stuff and it rains down. And they were actually able to precisely identify where these supernovae may have occurred, assuming they're from these groups. So by modeling the expansion rate of radioactive debris clouds from supernovae and comparing this to the seafloor sediments and the trajectories of the clusters, they were able to figure out that two supernovae at distances between 90 and 100 parsecs were responsible for these layers of iron on the Earth and in our solar system. The closest occurred 2.3 million years ago, and the second closest exploded about 1.5 million years ago, based on their estimates. And they even have estimates of the masses of 9.2 and 8.8 solar masses of the progenitors, based on the amount of iron that they were able to measure globally. The remaining supernovae that form the local bubble contribute to a smaller extent because they happen at a larger distance. And so it's just the closest ones that actually would create a measurable signal. And you can see in this graph here, the local bubble actually blows out this way. This direction here to the right on X is towards the galactic center, where there are other denser interstellar mediums. So the bubble has been blowing out away from the center of the galaxy into the less dense interstellar medium. And it's actually created a chimney all the way through the galaxy. So really interesting what you can learn by putting together all of these hints and all the sources of data that we have these days. We can actually tunnel down and figure out what may have been happening in our neighborhood a couple million years ago. So that's pretty cool. Thanks.
No, thanks, Al. I just actually had a quick question. You're mentioning about the dangers of close-in supernovae. With these supernovae, do you know if there are any extinction events which are associated with them?
No, there's nothing that people know about in 2.2 and 1.5 million years ago. Based on people's best calculations, these supernovae at those distances, it may have been visible during the day, probably as bright as the full moon, but wouldn't have had any other real effects locally.
All right, thank you. Thank you. All right, so now we'll, just before we move on, I'll just say it is an exciting time for astronomy. I don't know if for those of you who heard the news recently, there was a large bolide that's been filmed over Arizona, which lit up the night skies. It exploded, left a smoke trail. And there was one over our skies earlier in the month too. So, keep your eyes up there because there's a lot happening. So we'll now go to Gordon and his report on the transit event.
Good evening. Now, before I start, I'd like to, all of the photographs here were taken by different people who were participating in the event, and I haven't credited them, but I'm going to thank everybody ahead of time. So Monday, May the 9th, dawned bright and clear with a tinge of excitement and a large dose of relief in the cold morning air. This was the morning of the Mercury transit that the Mercury transit event that Mike Mogadam and I had been working on since the end of March. And it's a well-known fact that the rarer the astronomical event and or the more planning that goes into it, the greater the likelihood of cloudy weather. It all began in late March when I received an email from Randy Atwood, the executive director of the RSC in Toronto. He'd been at an award ceremony and was approached by the science minister, Christy Duncan, and she wanted to hold a star party on Parliament Hill and have an event during the Science Odyssey week in early May. They discussed the possibility, and Randy suggested an event for next summer that would tie in with other RASC centers and be held simultaneously across the country. And she agreed that that would be a good idea, but she really wanted an event for the week of the Science Odyssey. So when I received Randy's email, I knew who I needed to make this event happen. But he'd been shying away from things since his term as meeting chair in the past couple of years. Mike Mogadam was that person, and I knew that he was the one that could really make this happen. Unfortunately, he can't be with us tonight. Fortunately, he became excited about the project immediately, and he didn't require a whole lot of coaxing. So I emailed the minister's assistant, and we set up a conference call for the next day, which was April 1st. We all know what April 1st is, and that should have been my first clue about what we were getting into. So we proposed the Transit of Mercury event as the thing we should do for Science Odyssey. Through the discussion, we suggested that we could provide 20 to 25 telescopes and about 30 volunteers. We explained that we would need access to the hill to offload equipment. We'd need AC power to run some computer monitors. We'd need a few tables, a tent, and an awning. And in the event of rain, we'd need a backup room inside Parliament, the Parliament buildings, with internet access. We set up another conference call for the following week to see how everybody what progress people were making. So at that time, we confirmed all of the points that we had discussed. We had confirmation for our volunteers, telescopes, everything else. And the minister's office didn't have anything. It was becoming clear that the central issue was going to be getting equipment onto the hill. And in a call after the conference call, Mike and I discussed the different things that had come up, and he came up with the idea of of us chartering a bus to get everybody onto the hill. We figured that this would alleviate some of the security issues for the RCMP, since there'd only be the one vehicle to have to clear, and it would give us the advantage of having all the volunteers arriving at the same time. As well, it would eliminate the parking issues, since nobody could park on the hill. I won't go into details on the subsequent conference calls, but I will say that it was really interesting to watch Mike's frustration levels increase. He's usually a pretty patient person. We went for a month with no answers, no resolution to any of the things we were requesting. Suffice it to say that we finally got confirmation less than a week before the event. Then, as those of you who were with us on the trip will know, we get to the security gates on Parliament Hill, and the RCMP have not been informed that we're coming. They were about to turn us away when our hosts happened by, and they were able to speak the secret password, and we were allowed into the castle keep. We unloaded the bus near the internal flame, and we carried our equipment up toward the steps near the Peace Tower. By 9:30, we had all of our scopes set up. and we were sharing the sight of Mercury in front of the sun with passers-by. Gary Boyle, our media relations person extraordinaire, had done 3 interviews, so lots of word out there, and he did more while on the Hill, appearing live on one of the noon news shows. But he wasn't the only one being interviewed, nor was he the cutest. As many of you are aware, our event made the CTV local news. No? Okay. And it also made the CTV national news.
25 telescopes and hundreds of people gathered on Parliament Hill today to witness an event of celestial proportions. They were there to watch the transit of Mercury. It started just after 7 a.m. and lasted for over 7 hours. In that time, the planet Mercury could be seen as a small dot slowly crossing in front of the sun. CTV's Eric Longley watched with them.
Left quadrant.
For 6-year-old Julia Webster, a rare glimpse of the heavens. So what did you see?
Mercury.
What did it look like?
It looked kind of grayish.
Okay, maybe not the most colorful glimpse of the heavens. What did you see?
I saw a dark dot on the sun.
That's Mercury passing in front of the sun, a rare alignment that only occurs about 13 times in a century.
You can always tell your kids or grandkids you saw Mercury.
Rare enough to bring over 30 members of the Royal Astronomical Society to Parliament Hill.
This is an opportunity to sort of share our hobbies and share our interest in the sky and everything.
Specially filtered telescopes of every shape and size pointing skyward, waiting patiently for that break in the clouds to reveal Mercury. It was much ado about a little dark dot.
But when you consider what that dot is, a planet traveling through our solar system, that's pretty impressive.
And educational. Science has learned a lot from planetary transits, including how to spot planets orbiting other stars.
They do is they look at stars for 21 days to see if a star has a wobble to it. Like our sun has a wobble because the planets are going around it. And up to now, over 1,000 planets have been documented around distant stars.
The event on the Hill had science to spare for the gathered crowd, including a couple of prototype space rovers. The day helped kick off Science Odyssey, a 10-day celebration of science by the federal government.
There it is.
But it was Mercury that stole the show. The little dot that left a big impression.
Because it looks kind of cool.
Eric Longley, CTV News.
A rare celestial event is creating a flare-up of excitement for astronomy fans. Mercury crossed in front of the sun today, something that only happens about 13 times a century. Local astronomers set up their telescopes on Parliament Hill to capture the action and share the view with others. RASC reports.
You should be able to see now. Go ahead.
Amateur astronomist Boyan Skipanovic points his high-power telescope straight at the sun and shows how to spot Mercury on its fiery surface.
I see a very dark black spot, which is Mercury, and then just up to the right and over a little bit is actually another black spot, but that's a sunspot.
That's correct, yeah.
A small dot. Small dot.
That small dot is Mercury's silhouette. Too tiny to make out any details, but still a thrill for self-proclaimed astronomy geeks.
You can fit actually 300 Mercuries across the surface of the sun. It really puts things into perspective, you know. What's happening here on Earth is really just a small speck of dust in the cosmos.
Skipanovic is photographing Mercury's progress so he can share the transition with local students. About 25 astronomers set up telescopes for the event. All are equipped with special solar filters, a must-have for looking directly into the sun. And for many, this opportunity is a stargazing first.
It's just the way how the orbits are, because Earth is tilted on axis to a certain extent. So is Mercury. So just to get the coincidence of Sun, Mercury, Earth lined up, it doesn't happen too often.
Mercury last crossed the sun 10 years ago, but cloudy skies kept astronomers in the dark. Lifelong skywatcher Tim Cole says this is a rare chance to see the solar system in action.
Normally you look up, you see a star, you see a planet, it's there. And here we're actually sort of, yeah, that sucker's actually moving. That's actually orbiting the sun. It's actually passing between us and the sun.
And while these transits are rare, you won't have to wait quite as long for the next one. Mercury passes in front of the sun again November 11th, 2019. Sherry RASC, CBC News, Ottawa.
Okay. So by 10 o'clock, people were streaming onto the hill, and the weather was cool and partly cloudy until about sometime after 11. The sky wasn't an issue. But by 11:15, we had much more cloud than we had patches of blue. But the crowds kept coming. Fortunately, we had enough holes that we didn't miss too much, and everybody who wanted to look at Mercury got an opportunity. By the time the science minister arrived, as we mentioned earlier, she's connected, the clouds had lessened. The Museum of Science and Technology had set up the display, which you saw in the video, and they were freezing vegetables in liquid nitrogen and smashing them on the table. So beware of the broccoli shards. They were also creating tornadoes in large beakers, which may explain the red slippers I saw lying around there. And the Canadian Space Agency was there too. They had brought 2 experimental rovers, and they were demonstrating their capabilities inside a roped-off area. Science Minister Kirsty Duncan and the Transport Minister Mark Garneau were scheduled to speak at 12:30. Afterwards, it was introduced to the minister, and it was my job to show her around to the various displays we had set up and be sure that she got to see the transit. Jim Thompson was shooting video through 2 different scopes, and one with hydrogen alpha and one with the calcium K. And here you can see my able assistant explaining things to the minister. Minister Duncan made her way through the group and stopping to talk to several people and having another look at the transit. Okay, she spent time with the science and tech people and the Canadian Space Agency rovers, and other than the minister, nobody other than Julia got inside that roped off area. But the minister herself called Julia over and said, come in. Minister Duncan stayed for about half an hour, maybe 45 minutes. We stayed until almost 3 o'clock. We had clear views of the transit until the last 2 minutes. So anybody looking for 3rd and 4th contact was out of luck. We calculated that we had about 2,000 people in attendance at the event. And as you saw, we had incredible news coverage. It was also covered on national, the CTV National News. They interviewed Julia again on that one. And it was a different interview. Minister Duncan and her staff were extremely pleased with the event. And in fact, we're in talks right now to have another star party up there, this one in the evening, sometime mid-October, although the way we're moving, it might be September. Sorry? You mean August? I did mean August. I don't know what I said, but I did mean August. Yes. So to sum everything up, I would say that this was an amazingly successful event. And this couldn't have happened, and he's going to shoot me for saying this, but it couldn't have happened without the organizational skills of Mike Mogadam. Mike's knowledge from years of organizing CARP star parties and other outreach events served us really well on May 9th. But even with all of this ability and attention to detail, the event would not have happened without those of you who volunteered your time, your equipment, and your enthusiasm. You are the ones that give this center its strength. You are the ones that make it possible for us to do amazing things. On the Thursday following the transit, Minister Duncan hosted a reception to officially thank all the volunteers who participated in any of the Science Odyssey events. When I spoke with her, she asked me to please thank everyone who participated in the event. So to everyone who helped make this event a wonderful success, my sincere thanks, and that of the minister. And Julia, that includes you. Thank you.
Thank you very much, Gordon. It was a great event. I was there. I'm sure everyone had fun. And now I think Gary Boyle's going to have to look out because I think Julia might be hankering for a spot as the face of RASC Ottawa. So now, Brian, if you want to come down and give us a recap of the events of the GA in London.
Thanks, Roman. I'm surprised you didn't have a comeback to that earlier comment. Didn't you study retort law?
Did I study what?
Retort law?
Oh, I didn't hear it.
Okay, never mind that. Never mind that. All right.
Don't open with it, Brian. Don't open with it.
There. Another door prize from the GA. We've got a number of slides that Chris Tarrant very kindly put together for us. Rick Wagner was representing Kingston Centre at the General Assembly, and Rick's going to talk about the business portion of the event. So go ahead, please, Chris. Thank you.
Not sure which meeting this is, but basically there are two major portions to the GA. One is the fun part, the interesting speakers, the social events, the all-night, and I mean all-night parties. I think I got about 15 hours sleep in the 5 days we were down there. The other side of it, of course, is the formal reason for the General Assembly, and that's all the business stuff that has to happen. So the first thing that we do is, and I want to thank Brian for letting me speak about this. He's covering all the fun stuff, and I get to do the business part. But actually, I enjoy the business part. I've been doing national council stuff for I can't remember how many decades now. But we start off with a national council meeting, which is sort of the advisory board to the board of directors. Then there's the annual general meeting, which is for all of the membership, and then there's a quick little national committee meeting after that. This is the actual board of directors, and I'm going to pull a brain fart here and not remember who they are. Randy Bottom on the left, Colin Haig, Chris, Charles Ennis, Chris Gaynor, Susan Yeo, James Edgar, Robin LaForêt, Craig Levine, he's our new president. Oh, and then Heather Laird, right. And then in the back was Dennis Gray, who has been our longtime treasurer, speaking, of course, to the financial matters and stuff. So this is the actual board of directors that makes the decisions for the organization. Then each center sends one or two national council representatives who are there to provide advice. So we do a bunch of things to try and support the board. They can come to us and ask for advice or information. We provide ideas back. One of the interesting things they've added to the meetings is an exchange. They start off the first half hour to an hour of the meeting, and I know some people think that's way excessive, but it's basically each center gives a little report on things that have happened recently or things that they're doing at their meetings. So, for instance, we learned that the Toronto Centre, I don't know if you knew, had taken over the David Dunlap Observatory as an outreach facility, and the town of Richmond Hill has since pressured the development into stealing it from the centre. So they are now proceeding to court action because they have signed contracts and so forth. So there's going to be lots of excitement there. Learned about some interesting activities. Thunder Bay has a suggestion box at every one of their meetings. They have a participation draw once a year. Every time you come out and volunteer for every member of the center gets a ticket to put into the draw box. Then every time you come out and volunteer for an event, you get another ticket to put in the draw box. At the end of the year, they have a draw for a $150 gift certificate from a local vendor. Cool idea, encouraging volunteers. Winnipeg Centre doesn't pay for their meeting spaces, and in exchange for that, they give the college where they meet a $500 a year scholarship. An interesting thing to think about. I was able to, on behalf of Brian, who was unfortunately involved in another matter, I was able to report on the Mercury transit to National Council, and let me tell you, there were oohs and ahs all over the room. Nobody could believe just how important this was. I said, this is probably the best science outreach event in the RASC in like the past 10 or 20 years. And I just, it's miraculous, and everybody was stunned at the impact that they feel it's going to have. And I extended our thanks and the Society's thanks to Randy Atwood, of course, who initiated the whole thing. So what other business did we have at the meeting? Well, not a great deal. There's a new Observing the Moon certificate coming out, a smaller one than the Isabel Williamson one, which is pretty challenging. And there's an astro imaging committee has been formed, which is now going to start issuing astro imaging certificates. A fundraising committee has been stood up to try and get a better program going for trying to raise funds, look for sponsors and donors and stuff. And connected with that, I don't know how many of you have seen, Subaru is now a formal sponsor of the RASC, and you'll see that on some of their advertising now. So that was the first National Council meeting. Then there's the annual general meeting, which is where all the membership gets together and votes on things. The only big thing I can think of that was mentioned there is that in 2018, it will actually be the 150th anniversary, the sesquicentennial of the RASC. The first meeting of the Toronto Astronomical Society was in 1868. And so as a result, they're developing a logo for the 150th anniversary. And I think what's really interesting here is that one of the items on the logo is a large comet with specific reference to Ottawa Centre member Rolf Meyer, who of course discovered four comets, including the first comet ever, in fact, it might even be the only 4 comets ever discovered from Canadian soil.
Doug George.
And, oh yeah, Doug George also discovered one, yeah. So Rolf was the one who kicked it off. And the interesting thing about Rolf's observing was everybody at the time was saying you use a small scope, 6-inch, something like that, maybe even a 4-inch refractor, 2 or 3 degree field of view. Rolf said, no, that's wrong. Use a big scope with as wide a field of view as you can get. So the 16-inch with a 1 degree field of view eyepiece, and everybody said, no, you're an idiot. So he said, okay, boom, here's a comet. Am I an idiot? And they said, well, you were lucky. Here's another comet. Well, okay, here's a third comet. After that, they're sort of going, I think Rolf has something there. So then we went on to the second National Committee meeting, which is on Sunday morning. Unfortunately, it's quite brief. Its main function is to reestablish the various committees that function to carry the society forward. So the main reason I accepted Brian's generous offer to handle the business meeting of this talk is that I want to encourage people to contribute. The members here, if you're not a member, you should be a member, and I encourage you to join, but if you are a member, you should contribute. This is a terrific society, and it's only through our contributions, it's our society, and it's through our contributions that it moves forward, that it gets better, that it gets stronger, that it serves us better. This gets back to something else that Brian will be talking in the first National Council meeting. There was a strategic planning session that I'll let him cover. But the whole idea is how can we develop the RASC to improve it? You know, how do you feel about fee increases? Well, if you're on the board of directors or the National Council, you can have an influence as to whether we get fee increases or not, because there are some people pushing that we should have some significant fee increases. You have ideas for improved services to members, new programs that you'd like to see implemented. Some of the things that we were discussing at the meeting, canned presentations for public interest groups. So if you wanted to give a talk to a local Brownie group or a seniors group, you would be able to go to National, perhaps, and download a set of slides, a set of notes, answers to questions, boom, boom, boom. You can put that on a computer and take it out and give presentations and look like an expert. Group purchases, group discounts on things. a collection of mini handbooks, little sort of 20-page things on how to do astrophotography, how to observe variable stars, how to learn the constellations, whatever. So if you have particular interests, you can join one of the committees. There's various committees taking on various activities. One of the programs they're trying to do now is ask for volunteers for little specific tasks. You don't have to get on a committee. You don't have to join the board of directors. We're going to implement remote observing program. We need 6 people to come together, do this for 6 months, and then it's over. So, if you've got an interest. So the other thing, if you want to go whole hog, board of directors. There's 9 directors, 3 positions open every year. So you can put your name forward. The last thing I can encourage is somebody mentioned that the web is the largest publication the society puts out. And it's so easy to do up content for the web, the center level or the national level. Write something and have it put up there. Any questions on that portion? All right, Brian.
I'll keep your bullets.
Sure.
Oh, there we go. Okay, great. Thanks. Yeah, thank you, Rick. The strategic planning session that Rick was talking about was organized by Dennis Gray. And what he was looking at was he organized some breakout sessions. So what we did was we made little syndicates in the room, and we started discussing various aspects of the RASC's place in Canada, the place of members within the RASC, so who's benefiting from what. So the specific breakout sessions they covered were what's the RASC's value to the scientific community, its value to centers, value to members, value to the public, and is it financially sustainable? How do we make it financially sustainable? And at first there was a little bit, I think there was a little bit of reluctance, people getting into this, like how are they going to approach it? But then once they dived in, you started getting people talking about these various aspects, and they started jotting down ideas, and we did it fast, and put down all these ideas. We pasted all of the idea sheets on the bulkhead, and then we were given a bunch of green dots, sticky dots. And what you did was you went up at everybody else's sheet there and said, I like that point that they made there. I like that. So basically what you were doing was liking some of the comments. And the interesting thing was you could see that there were clusters forming across every one of these sheets because almost every one of the sheets had something to do with public outreach. What is our position? Because the RASC's one of the main mandates is our interaction with the public, is it not? And people focused on that very strongly. So I don't know what got into me. You'd think that after 25 years in the Navy, I would have learned not to volunteer for anything. But I've volunteered to join Robin Foray and his team as part of the strategic working group. So in preparation for a fall council meeting, we're going to be putting ideas together, see if we can distill some of these things into ideas that the board could take away and run with. So it was very interesting. When I went to this GA this time, I went under a number of hats. First of all, I'm the National Council rep for Ottawa Centre. Rob Dick is the other National Council rep. But before I became a National Council rep, about a year and something ago, I had been talking to Peter Jedicke at London Centre, where the General Assembly was held, and he had wanted me to get out and do a presentation, do a workshop. So what I ended up doing was joining Erica Ricks, and I don't know if you've seen any of her sketches in Astronomy magazine, or if you Google her, Erica, E-R-I-K-A-R-I-X, Erica Ricks, and you're going to see some stunning astro sketches. So we shared some workshop time. So in a sense, I opened for Erica, and I gave it just a quick 30-minute, like we've done on our own center before, with the index cards and a golf pencil, just to show people, you don't need the beret. I even took my beret off in the room. You don't need a beret and an easel to do astro sketching. All you need is a little index card, whatever grubby pencil. You can do it with a smudge finger, and you can start to do it. And what it did was it helped people get over their heebie-jeebies of, well, I'm not really an artist. So it was a good way to loosen people up, and when they got into Erica's much more detailed workshop where they could learn specific techniques, I think they were much more willing than to go and put a mark on the paper. So that was really good. I was glad to be able to do that. So what's up next there, Chris? All right. So Chris Tarrant and Rick Wagner there. Just proving that we're all there, right? All right. Some of the speakers that we had, one of the opening speakers, astronaut Jeremy Hansen. Anybody recognize that plane behind him? Sabre. F-86 Sabre, that's right, yep. Yep. You can see some of the, there were some of the other speakers listed there. Robert Jedicke, who's the brother of Peter Jedicke, one of the co-organizers, came out and did some presentations. You see David Levy's name there as well. Tina Pullman, another great presentation. I have to say right off the bat that the organizers for this, the couple of main organizers, Dave Clark, Peter Jedicke, Dave McCarter was involved there. Also, Dave Clark's wife Angela, his son Everett. These guys, the work they did was phenomenal. And I have to tell you, one of my other hats that I was wearing when I went to this GA was as a scout, because of course I'm chairing the 2017 GA in Ottawa next year. So I got a good scare there. That was good. So. But what the value of that was, we've learned some things. I've met some people there, people, David Parfait and other people who were there, and we're putting ideas together that we saw there that we can apply to our own General Assembly. And that's the way it is. It's always a handoff, right? So there's Jeremy Hansen. Yep, very good speaker. That's Erica Ricks. It's a little bit blurry of a photo. There she is there with her husband Paul. He's a Brit. He flies executives around here and there. And that's Erica. So if you've ever seen her column in Astronomy magazine, and she was a real delight. The both of them were just lovely to work with through the GA. Right. This is the Helen Sawyer Hogg Lecturer. That's Dr. Ann Hornschmeyer, and. We had a number of very good presentations throughout. So they had some key presentations. They had some local presentations. So it was a nice mix-up. We can go to the next one there. We had a nice mix-up of activities there. This is their astrophotography display. And the event was shared between the GA, the London RASC, and AstroCats. It's the Canadian Telescope Sellers, I think. Is that what it stands for? All right. So you had a number of booths around there. The RASC had its own booth. So it was very interesting to go and actually talk to people from National Office who deal with the merchandise sales from National Office. One of the vendors there, they had some very nice door prizes. Rock Mallon, who we know from Ottawa Centre, was there, and he was very, very generous in donating door prizes to the event. So there were no GA door prizes. It was all handled through AstroCats, and they were extremely generous that way. So it was some interesting displays there. I mean, if you wanted to pick up a little bit of gear, they had some good prices on things. So it was very nice. Chris? We went out for a barbecue on the one evening, and there we are there. Yep, Bridget and Brian. There's Chris and Louisa. Okay, at the barbecue. This is the president, the outgoing president, Jim Edgar, giving the President's Award to Terry Dickinson. Of course, we know as Terry Dickinson has stepped down as editor of Sky News magazine. Gary Saronic has taken over the editorship, but it was nice to see that Terry's work, all that work he's done over the years, was acknowledged nicely. They have two roll-off roof observatories. We had the barbecue down at their observing site in Fingal, which is down toward Lake Erie. A couple of roll-off roof observatories, beautiful instruments there. There's Rick Wagner, checking things out. There's David Levy. That's not. Name this aircraft. T-33, yeah, it's a trainer, that's right. So that's about all the plane that was there, just where the canopy goes. It's chopped off in the back, and it's chopped off pretty much in the front. And so some guy hauled it in with a truck, and there it was, so all aboard. Wonderful meteorite display. It was just amazing. There were meteorite samples there, and there was a box of gloves there. You can pick these things up. They had samples from Tagish Lake, the Tagish Lake meteorite. Remember the one that landed right on the lake? Alan Hildebrand was involved in the recovery. What do I have there? Meteorite, Ukraine. Oh, this is they had meteorites from asteroids. So they're pretty sure they can match an asteroid. If you take a little sample of the meteorite that's landed on Earth, you burn it, you get the spectral signature of it, and you take a spectral signature of the light coming off various asteroids, they can match them up. Isn't that great? Okay, here's the banquet. Now, what was interesting was they didn't have a banquet speaker, so there's no main speaker for the banquet. But what they did was they did the acknowledgements. They did all the good things, thanking all the right people for the great work they had done. But it was a good event. There's Chris Tarrant up in the booth. Chris, you gonna put your light on up there for a second? Hard to do? We'll put our X-ray eyes on. So Chris Tarrant getting his service award. So congratulations to Chris. And here's Rick Wagner getting that's a Williamson Award, right? Yep. Oh, and the lunar, I knew there was one more, and the Lunar 1000 Challenge. I knew there was a second one there. So well done, Rick. Good. Okay. All right. So we got to the presentation now, because what we did at each GA, whichever center is going to be presenting the next year's GA, usually shows a little promo video or advertises the upcoming GA for the following year. So that's what I did. On the way down to London, Bridget and I stopped in Oakville at a supplier and picked up a couple of the shirts. I gave away a few as door prizes there, and gave one to the new president, Craig Levine. And I have to tell you that the things that I've been hearing from Craig Levine and the way the new board is all set up, I think you can expect some very, very good things coming out of National. All right, so what I did was I threw up the promo video there. Yep, and just before we, is that what's going to run next, Chris? Yes. Okay, and just before we do that, last month I showed everybody just the rotating logo. Remember that? And that's the work of Jonathan Buchanan, who's sitting up in the back. Really good work on turning an idea that Tim Cole and I had, we went iteration after iteration to come up with a design that's simple, tells a story, and Jonathan did huge work in terms of animating it. And then we took all of this and we took a bunch of photographs that Tim had taken, I had taken, other people, and we put them into, we were running quite late with this, so we couldn't get into a slick video, we'll say. I know Eric Kujala had offered to help us early on, and things just, I had so much work I had to do for my work that I didn't have time to do a slick video. But what we came up with is something I think it's reasonable. And what I told people there was that, I mean, what's a GA? I mean, when you go to a General Assembly, it's like a Seinfeld episode, so it's whatever you make of it. All right, Chris? Thank you very much. So the idea was just to show people a little bit of an idea of what they could expect in terms of some of the tours, some of the locations, that type of thing. The sign there, volunteers needed. Tim has got a sheet of paper there. If you're interested in volunteering to help with the General Assembly next year, we definitely are going to need some good people in the right positions. We're looking for some key captain positions, especially in terms of catering. So somebody who can manage the banquet, the reception, the barbecue, that type of thing, as their own event, so that we know that it's all, and you have your own whatever volunteers you need working with you to make that happen. We're looking for a stills photographer. Transportation, we need a transportation captain. So if we're looking if we get a bus organized for Chuck Godale's tour down to the Holliford Crater, or running out to the Deafin Bunker, that type of thing, or off to the Science and Tech Museum to see the telescope there. Ordering merchandise, we need a few people in the right places. Registration desk is going to be a big one, and we have some people already identified who have some experience there. But if you're looking at pitching in, it would be great. And we'll be coming up with more points later on in terms of what areas we still specifically need more people. All right, so it's a community event, and it's going to be us. I know I had some comments already about from somebody saying from London, who said he was offering to do a presentation. And he said, well, when you put out a call for speakers, and I said, actually, our slate is almost full right now, because we were urged to put a program together early on. And one of the things I knew when I volunteered to chair the organizing committee was that I wanted to showcase Ottawa Centre. You saw some of the other speakers we're bringing from the outside. We have such a depth of talent in the seats right here, and in our wider membership for Ottawa Centre and the environs, that I think we can afford to showcase that. All right, so see Tim. Thank you very much. Roman, thank you.
Thank you very much, Brian. Okay, so we've reached almost the break. Just a few last announcements. First of all, there's a member, there's someone here in the audience who was at the London GA, and she's a member from Victoria. Her name is Laurie. I met her earlier. Welcome, Laurie, and thank you very much for making the trip all the way out here. Welcome to the Ottawa Centre. There she is in the purple. I'll just make a few, two quick comments about the last presentation. I was kind of intrigued by the idea of the Thunder Bay Centre had for, tickets and drawing for participation, because it sounds a bit like the Hunger Games to me, but a lot of fun, as the Hunger Games were. And I was really interested to see that the RASC is nearly 150 years old. I mean, I'm not sure, it was mentioned that it was the Toronto Astronomy Society that started. I'm not sure when it became truly national, but if it would have been one of the first, it's one of the first, I would guess, non-federal government organizations that's truly had a national reach. I mean, Canada would have been barely a year, if that old, when the... then it would have been one of... If it got its royal charter then it would have been one of the first non-federal government organizations that would have been national. It would have been very interesting. So if I want you to cast your minds back to February, where we had that excellent presentation by Kelly Jordan on the cookbook. Now, she's been busily working behind the scenes and has had it translated into English. It's available in English and French. And it is available if you want to contact her at this email address. There is a price she'll quote you. And in her words, all proceeds are going towards Astro Stuff. That's her word. So, it's all going to a worthy cause, and it's to support a young member who put on a presentation that was, I think, had us all mesmerized. Yes?
If you guys want to book tonight, you can just come see me. I have some coffee.
She's here. Okay. I can't see you. I can't see what you're wearing in the dark, but there's Kelly is here, and so you can have a chat with her if you're interested in getting a copy of the book. So right now, so it's the break. It's now 8:43. 10 minutes, please, and we'll get right back into the meeting. So tickets available up at the front. See you in 10 minutes. All right, so we'll get right into the next presentation. It'll be presented by Chuck O'Dale, although it has other, it appears to have other contributors as well. Chuck has been a longtime member, and his particular passion is craters, and this is for probably more than a decade now. It's been a series of talks on craters, which he calls really big holes in the ground. Take it away, Chuck.
Thanks. Yeah, I've been doing it for a while. It's Eric. It's amazing. Eric and I met how long ago now, Eric? 10 years. 10 years. Eric and I had a mutual dream to explore a crater, and we made it happen. It was just awesome. So this is dedicated to Eric and Jillian, my partner in the airplane, and we did all kinds of stuff all the way across the country. So let's see if I can figure this out. Oh, whoop, wrong way. There we go. Okay, that's just an example of what we've done. The tracks you see is a satellite tracker that I had in the airplane. And you can see we've gone from coast to coast to coast looking for craters. And unfortunately, I did not have the satellite tracker for Eric and I's explorations. But the one that we went to was the Pingula crater right up here. That was our lifelong dream that we had. I made a presentation of that years ago. It's on the website, so please take a look at it. But we actually went around that point in the airplane, and down here we saw another crater. And up there was a U-boat weather station during World War II. Not too many people know about it. There's an exhibit of it in the War Museum. And one of the things I like to fly over, in addition to craters, is war sites, Civil War, War of 1812, and so on. So not too many people have flown over that U-boat area. Anyway, as you can see, I've gone coast to coast. The craters here are all pretty well in bedrock. You can actually probably see a couple here. Of course, Manicouagan, Mistison here. There's a little one there, and piles of them. But in the prairies, I'm going to get to in a few minutes, it's wall-to-wall craters. One thing we found out as we were going across, there's so many of them there. Okay, so what do we got? These are the ones that we know of right now, and there are approximately 340 yet to be discovered. And we just might have one at the end of the meeting. That number, 340, is going to be on the exam, so remember it. I'll start off by what I'm doing this evening, basically, is going through the news of the last year of the research done in impact, geology, and so on. The empirical evidence that I'm going to quote are all on papers on my website. If you want to get into it deeper, all the papers are quoted, and as I say, each paper is probably an hour's worth of reading. But I'm just going to zip through them as we go. Now, right off the bat, this one here, it's still a mystery. Nobody knows, and if we ever solve that, I don't know if we can do it in my lifetime, but I'd love to know what caused that. But the one I want to talk about is these two right here. Now, the first thought, and the thoughts up to the last few years, is that that was a twin impact. What are the chances of two craters impacting almost in the same spot? But this is exactly what happened. With the latest technology we have for dating, the latest argon type dating policies we have, the craters themselves now are, this one here is almost twice as old as that one, believe it or not. The Clearwater, these are the Clearwater craters. Clearwater West was just before the major extinction at 250 million years ago. But believe it or not, Clearwater East was almost twice as old. And this has been documented with the latest dating methods, and it surprised everybody. Flying over it, this is the crater rim. You can see the rim's right between the two craters when I flew over it almost 12 years ago now. That's the rim there that I was going over. I'm sitting about here looking that way. And believe it or not, I can't, it still boggles my mind the fact that these two impacts are side by side. Just amazing. And this is what the planet looked like at the time of these impacts. The first one, the east one, is, you can see the equator was south of the equator, and the west one was north of the equator, the way the continents worked. Shows you our dynamic Earth has been moving, and it still is. Where are we here? Okay. Now, this is a brand new, with my website, I get a lot of emails back and forth from, that's actually how Eric and I met. He looked at my website. There's a chap in Florida, a geologist, looked at a formation just on the outside of Miami Harbor. This is the Miami Harbor. And this is under about 30 feet of water. And he is in the process of trying to get some kind of research going on there. Of course, with the shipping traffic and so on, he's going to have a difficult making any drilling or so on, but well, there's all kinds of sinkholes in Florida, of course, but if it is an impact, it's going to be one of those ones that haven't been discovered yet. Now, I mentioned that the prairies are wall-to-wall craters. I just wanted to document the Manson crater here. This one here happened about 10 million years ago, 10 million years just before the dinosaur extinction, the Chicxulub crater at 65 million years ago. So about 10 million years before that is when this one happened. But I just, first of all, the news that went with this is that they found a lot of the impact ejecta all over the prairies at the layer of the date of that impact. So that research is ongoing. But I just wanted to show you underneath, this is what's there. The drilling has documented the central peak and the breccia and the impact melts around it. So as I mentioned, across the prairies, it's wall-to-wall craters. I made a presentation about that, I think, last year. And it's, and they're still being discovered. So as you say, we just might get lucky and find one. I'll get into that. This one here is in the Rocky Mountains, undated, and we're really not sure that it is a crater yet. Of course, with the Rocky Mountains, you know the geology has been humping rocks up and down, back and forth for a few million years. But what we have here is the Howell Creek structure, and it is right in this area here. And what we suspect it is a fossilized slump around the crater rim. If you look at that rim, that's actually the Tycho rim, and you can see when the explosion happened, basically it's the mv squared impact. It's a large energy transfer causing a large explosion, instantaneous. And the crater is unstable in itself, and as the dust is settled, you can see the edges of the crater is actually collapsing in on itself, almost like a mudslide, and that's called slumping. And we suspect that the Howell Creek structure is actually a fossilized slump of an edge of a crater. Of course, the fault lines, we don't know where the other half went to and so on. But that's the ongoing research there, and I'm kind of looking forward to find out exactly what the conclusion is to this one. The Brent crater, Eric and I, we canoed through this guy. It was kind of an interesting little expedition. And we had to haul it across here and then haul it up a hill up to here. I'm not too excited about hauling canoes, but to explore this thing, we actually found some breccia. But what's the news about this guy? The latest news that we found out. Actually, first of all, this is the aerial picture. I think it was in the early 50s. That was shortly after the Pingula crater that Eric and I explored, when the government started looking at all their aerial photographs to see, well, there must be some other craters around, and sure enough, just north of here of Ottawa is the Brent crater. And from there, they did all kinds of drilling and so on, and all the explorations to actually confirm with impact melt, breccias, and so on. But the news about this one is now with the advanced analysis that they've done. Oh, by the way, this is my airplane, and Eric and I flew over this a few times. Actually, we flew over this in August, and there was a snowstorm up there while we were doing it. It was kind of cool. But, yeah. This is the meteorite type that they have documented that has actually impacted there. The paper describing it is fairly detailed, and I couldn't understand half of it, but I'm fascinated the fact that they can actually identify the impactor. Now the next conclusion, I guess, is defining which asteroid this impactor came from. Research is ongoing. And this is the breccia. This is an example of the breccia that Eric and I did find in the crater when we were canoeing. For scale, this is my geological hammer here. And the breccia itself is, when the impact happened, you've got all kinds of different rocks exploding and then mixing in and spinning themselves together. So basically, you have all kinds of different bedrock all mixed in together and then solidified into one. It's almost like an ice, a GNEISS type rock. But when we found that, that was our eureka moment exploring through the crater. The next one I want to describe is the Wanapatai. This is the one right beside Sudbury. Actually, this is an old photograph, and actually you can see the smoke from the Sudbury stack coming up over here, back in the old days. I don't know if back in the 60s I drove up there and it just looked like a moonscape from the smoke. It's been pretty well cleared up now. But the point I want to make out here is that they identified the bolide that impacted here. This actually, I'll just go back. The airplane, when I took the picture from my airplane, I was right up here looking south. And just before I go on to the next one, right here is the Sudbury Igneous Complex. This is actually an impact crater 1.8 billion years ago, several billion years before this one. So again, these are two impacts that happen side by side. So it's not as rare as we think because we have two in Canada. So where am I going with this? Well, okay, well here I am at the north looking south now at the crater. And these are the gravity anomalies that we could document within the crater itself, which it did confirm impact. But again, we could identify the bolide that hit it, and it was from the impact melts that happened at that we can document from Wanapatai crater. Here's the Wanapatai crater, and as I mentioned, the Sudbury Igneous Complex right beside it. Now this is a fascinating, if you ever have a couple of days and you like rocks, you have to go to the Sudbury area. Up here is called Windy Lake. There's a highway that goes through here, and from there to there, you get, I'd say, more than 5 or 6 different geological rock cuts. Totally different, and they're all from the impact. Now this impact this is just the bottom part of it. It was over 160 kilometers wide at the time, 1.8 billion, billion with a B, years old. And what's left is just the bowl, the bottom of the bowl that has been modified with a continent collision. There's this part here was separate from here and basically collided this way, causing the circle to actually get squished. I've been told by geologists that all the mine shafts in this little area, if you stretch them out end to end, you can go from Halifax to Victoria underground. And it's all a honeycomb, so I suspect maybe another 100 years it just might all collapse from all the honeycombing. A fascinating area. Let's look at my notes here. First of all, they where are we? Yes, I wanted to mention that there's been a couple of studies. First of all, this is another shot from my airplane. Now this is Lake Wanapatai. The first shot that I took of Wanapatai, I was looking this way. Now I'm looking this way towards it. And this is the area at the edge of the Sudbury Igneous Complex. and this is the base of it. It's flatter. This is basically the bottom of the bowl. Now, within that, within the last couple of years, 2 studies. First of all, zircons. They are a rock that essentially is erosion-proof. They found zircons in rocks in Australia that are billions of years old, but these zircons were formed in other rocks and were deposited within these different rocks. Well, the point that they found here is that the zircons dated at this impact were indistinguishable from zircons elsewhere, found elsewhere. So the implication is that zircons could be formed during impacts from large bolides. Now, our planet has been peppered by bolides, constantly in the last 4.5 billion years of its age. Just look at the moon. So these zircons that are all over the planet could have been formed by these other impacts. Of course, these impacts have been eroded, that they're no longer visible or even identifiable. So at 1.8 billion years, we're very, very lucky to see this one. And it's, as I say, within a day's driving distance, and it's well worth your ride up there. But there's something else we've found with it. This here is one of these smokers from under the ocean, just been discovered in the last couple of decades. And the hypothesis is that life may have started in environments similar to this. Now, continental drift, we suspect, has happened after the formation of life on our planet or around the same time. So the question is, well, could life have started here, the original life, or somewhere else? Well, studies, again, at the Sudbury complex have confirmed that the impactor in a shallow ocean is the same analog as a smoker under the ocean. And it would be the same environment that they suspect life had formed in the smoker could have formed in a crater similar to the Sudbury crater. So again, we have the window opening a little bit wider on how life formed on this planet. Could have been from the large number of impacts that did happen on our planet. Fascinating stuff. Again, the paper is quoted on my website, and it's well worth the read. Now, this, I'm going to document the Chicxulub crater. This is the crater that finished off the dinosaurs. Jillian and I we sailed by it in a 60,000-ton sailboat. We let somebody else drive. We just had our margaritas. But I was very fortunate to get this shot. It was just amazing. And the crater is just over the horizon. So that's the closest I've been to it so far, but eventually I want to set foot on it. But where exactly it is, you can see it right here. Whoop, right here on the Yucatan Peninsula. It was amazing that they noted the Brazos River up there. They didn't even mention the Mississippi. It's a lot bigger. So I researched, well, why did they mention this on this image instead of all the other major rivers? Well, the Brazos River actually is a mecca for fossilized tsunami deposits from the Chicxulub impact. So if you're kind of a rock hound and like to look at fossilized tsunami deposits, that's the place to go. And I wonder how that whale's doing. I was so lucky to get that shot. Kaboom, and that tail came up. And the second point I want to make here is right now there's a major drilling project at the Chicxulub crater to further identify the exact layers and to refine the dating of it. The dating has been almost precisely down to less than, we're down to a 100,000 year window, and they're getting better at it. So as we say, the research, ongoing research is, as we speak, they're still drilling. There's a couple of points I want to make here as well. Where are we here? The hypothesis is sorry. The birds that we have around here, of course, are dinosaurs, flying dinosaurs. Well, how did these birds survive and other birds didn't? Well, the thought is that these birds were not carnivores, they were herbivores. And the birds with teeth, being carnivores, they didn't have any more carnivores to eat, whereas the birds with beaks had lots of seeds left over there, and they made it through the extinction process. So that's one hypothesis that's running right now. Okay, where are we here? So, I mentioned at the beginning that there's a few craters yet to be discovered. And this one here is kind of unique personally to me as well. Eric and I just, within the last 2 weeks, were there. Exactly there. This is a picture taken from my old analog camera. Back in the days when I was doing search and rescue, it was an organization called Casera, and we had a civil air search and rescue. And we were doing a simulated search in that area. And I said, holy Mackinac, this is the exact area my father and I went fishing. So, of course, every spot that my father and I camped or fished at, I did a circle around and took a picture of. Well, there's a story with this lake here. My father and I, it was a day-long canoe to get up here. And we were in here trout fishing and getting our supper. And we're looking around, and my father just casually mentioned that, you know, this might be a meteorite crater. And I was 17 at the time. Actually, it was the last time we ever went anywhere because 2 months after I was there, I had basic training at HMCS Cornwallis. Like Brian, spent some time in the Navy. But anyway, so it's sort of stuck in my mind. Yeah, you know, it kind of looks like a crater because actually, look at this rim. All the way around it. Well, let's take a look at it. First of all, yes, it is kind of circular. And it's north of North Bay.
By the way, Chuck,
yeah.
The meteor crater in Arizona is squarish like that.
Yeah, that...
some craters are squarish.
Yes, they are. And that is from the impact that happened at Arizona. I can't remember the exact geological name for it, but essentially it's all in sedimentary rock that you know, you have faults left, right, and center, and so on. So when it impacted, it wanted to be a circle, but the fault lines around the crater itself were squarish, and it blasted out kind of a square crater. So if anybody looks at the Beringer crater in a picture, you'll notice, hey, it looks like a square, and it is. I had a brain meld here. I can't remember the exact name for it. But again, if you look at a close-up picture of the Beringer crater, you'll see a little white dot inside it. And the little white dot is actually a wreck of an airplane. Two commercial pilots thought, oh, let's fly inside it to see what we can do. Well, being a pilot, there's a few of our pilots in here, we understand what density altitude is. Well, the rim of the Beringer crater is just around 5,000 feet, which is a mile up, and it's hot. So these guys got into the crater. Normally on a straight flight, you'd have enough lift to fly, but these guys had to circle inside the crater, of course, increasing the drag of the airplane, and they couldn't get back out. Well, they did survive. Mind you, they were banged up, but next time you look at a picture of the Beringer crater, look for a white dot inside it. That's an airplane. Anyway, back to this guy. It is circular, and so we actually, Eric and I canoed in there. What happened? Okay, here we are. We canoed in there. I'll take two pictures. This one here, I'm an amateur geologist with my compulsory rock hound. Brian's not the only guy that can do that. Okay, I want you to just look at, this is the entrance to it here. So if I go back, I'm standing about there looking this way. And you can see where I am, and that's the crater edge there. So I kind of get a rough plot here, and my measurement of 50 degrees. Well, how did I get 50 degrees? Well, while I was climbing up there with my rock hound, and actually Jillian had the camera, this piece of birch branch here I held with my finger vertically with this guy on the edge to just give you an idea of the true angle and with a protractor on the image, you can measure 50 degrees. So that was quite the climb. It was about 30 meters. It was interesting.
Chuck, what is the angle of a talus slope?
Oh, golly.
Is it less than 50 degrees?
Yes, it's less than 50.
So that tells you something then.
Yeah, well, there's a couple of hypotheses here, but yes, you're quite right, Eric, and we're still looking, and you and I are going to make a presentation of it later. But the talus slope, what Eric mentioned, if you have a cliff and you have rocks falling off it, and eventually what happens is that you get a sort of like a slope from the cliff, and then a slope coming off it. That's called a talus slope. And actually the Brent crater has a fossilized talus slope. Thanks for mentioning that. But this is much steeper than that, and it is not a talus slope because it is the exact crater rim that we climbed up and down. And unfortunately there's no bedrock there, so I couldn't find shatter cones or impact melt or so on. But there's much more to document, and Eric and I and Jillian will be giving a presentation about that in the future. So anyway, you have to imagine 50 years ago I was in there with my father, and now here I am back thinking, well, geez, you know, it might be a crater after all. Who knows? Kind of cool. So I'll finish off as Al mentioned, or Brian mentioned, that there's bolides going flying back and forth here, a couple just recently over our skies. And it just shows you that we are in a shooting gallery. And actually, there we go, there's our square crater. If we look at it, it is actually squarish.
Where's the white dot?
I'm looking for it. I'm looking for it. Now, I think it, okay, where is
There's a white dot in the middle.
it is right in there, in that area right there. So this was from my old analog camera. So you know, with my digital camera, you might have seen it, but somebody actually went down and took a picture of it, and there was an N number on the wreck, and I actually did look up the accident and the fact that, as you say, you could fly in there no problem. If you flew across it, you could climb no sweat. But if you start doing a circle, you're in a steep turn. You're in a 60-degree turn trying to stay in there. And these guys couldn't get back out. So,
is that at about the 3 o'clock position, bottom of the bowl? Small one.
This guy, no, I think these...
3 o'clock position.
Over here?
No, right there. Right there.
Right there? Well, you know, that might be it.
There's a lot of line shafts at the bottom of that crater.
Yeah, there is. Yeah.
I think they pulled the plane out, actually.
Well, they might have by now, but the picture... It was gone?
No.
Oh, okay. Okay. Well, 10 years ago it was still there. That's, you know, but, very interesting. Anyway, so the studies go on. Who knows what we'll find out next, but thanks for your attention.
Chuck, when you were showing the picture of the Brent crater, the aerial one, just at about the 5 o'clock position is another structure that's circular that looks like it might be another companion crater.
Was it on the image?
Yeah.
Well, let's go back and look. Can we look?
Yeah, we'll have to be quick though.
Oh, quick? Okay. One of these guys?
No, there's the black and white one.
Was black and white? Okay.
There. This area here.
No, they're not. We actually looked in there. We looked in there for breccia, and it's just bedrock. There are a lot of circular objects in the northern part. Pardon me?
On the left side too, there's an arc.
Oh yeah.
Hills.
Yeah.
There's all kinds of this guy here. Yeah. There's all kinds of geology up there, and actually, you know, if anybody wants to go up with me, we can go up there with a geology hammer and see if we can find some shadow cones. Kind of cool.
Thanks, Chuck. Thanks, Chuck. Like your, I think I'd call your little Eric's editions O'Dare, right?
Yeah.
O'Dare. All right. So now we've come to the observations. We are unfortunately running a bit behind time, but if those who have given images could please come down. And we'll just go through you one at a time. Larry Stewart, Shane Finnegan, Taras Rabatiski, and Paul Cloninger. Sorry, oh, Shane's not here? No. Are you going to present? Sorry? Are you going to present his stuff? Or?
Yeah, I'm Larry.
Oh, okay, great, great. So Larry will present Shane's stuff.
I'm presenting my stuff.
And your stuff.
I don't know about his.
Oh, you just, oh, you don't, okay,
No, I
never
just
mind
know
then.
he's not coming here.
Okay, Shane's not here, so we might have to skip them. But anyway, if for those who are presenting images, could just be very quick, please.
Do you set up pictures or what?
No, you just, what do? You click right this button to advance.
Oh, cool. Good evening, everyone. It's my first time speaking here. I'll try to be brief. I'm an artist, and for the Mercury transit, this is a digital painting I did of the transit of Mercury, of course. For anybody who is an artist, or anybody here who does sketching at the telescopes, etc. Okay, some important things. Don't make the mistake of forgetting to bring paper and pencil. Trying to do your observations on an iPad is kind of like trying to put out a forest fire with a can of gasoline. It doesn't work well because the sunlight is a higher magnitude than the light your machine puts out, and it's a bear when you're trying to plot a point on a drawing you're trying to do. So anyways, when it comes to something like the sun, for those of us who simply have beta film, if you're trying to track a moving object like Mercury that's not going to be doing just a straight line transit that Venus did, for example, it is imperative, just as it is in navigation, to have a benchmark. Unfortunately, we had these wonderful sunspot groupings that changed, of course, throughout the day. And once being able to plot those in conjunction with the two that were just on the rim, as Mercury traveled in its quite elliptical path, as we were cloud dodging, trying to get images, you had so little time to plot the time index with the observation in comparison to the sunspot groupings. You're doing triangulation in your mind, same thing as if you look at a star map and you're trying to find the object in the sky. And that allows you to at least get a pretty good idea of where the object is. The reason that the image is orange is because, as anybody who has a solar filter, beta film, knows, it gives you a nice white image, but the sun isn't that color. So I always put an orange filter on, and it actually improves, it takes away some of the garishness when you're trying to see the penumbral features around your sunspots. And it gives you that lovely color, which is really, I think adds to the picture. So being out there for the entire event, this is what you had to do with the iPad. Fortunately, the microphone wasn't on, so all of the cursing and swearing wasn't recorded. But of course, the transit, started at 7:15, the first contact that we had. And as it went along, of course, when you're standing at your telescope, you're standing on the ground. But as your telescope, especially on an equatorial mount, changes, the image of the sun also changes. It sort of rotates. So you can just imagine what it would have been like trying to plot the ongoing position of Mercury if there had been no sunspots on the disk. Accuracy would have been something you know how to spell and know the definition of, but couldn't put into practice. Swearing, on the other hand, well. So having taken all of these observations, I then said, well, great, now that I was able to get everything right up to where we were located, the clouds parted just as Mercury's little hiney was leaving the disk of the sun after that fabulous show. And so I said, okay, now I can take these observations and I can plot them all. And so I'm quite happy to present to you the transit of Mercury from beginning to end. The gaps, of course, because my observations could not be done with the clockwork I wanted. I would originally wanted to do them basically every half hour, but the clouds did not cooperate. I wanted to do this picture simply because, besides being an amateur scientist, I'm an artist and a poet, and this is one of those rare times when astronomy means so very much more to all of us living on, as Carl Sagan called it, the pale blue dot. We've all seen oraries from grade school. We know that we're one of 8 or arguably 9 planets orbiting around the sun. But the transit of Venus, that most exquisitely rare and beautiful phenomenon, and a transit of Mercury are the only times in our lives when we, standing on this planet of ours, can look across towards our parent star and see one of the other planets
we can see that we're on that orrery as it too does its crossing in front of the sun. There's a disconnect when we're looking at the heavens. You know, you look at a galaxy, it's beautiful, it's wonderful, but it's mind-stunningly far away. It's not, I always said I was going to do that, okay. It's mind-stunningly far away, and you know, our connection to it is tenuous. But here, when Mercury and Venus transit the sun, it plots us firmly in the universe we're a part of. And it explains why we should be excited about astronomy. It's the here, it's the now, even though the distances are mind-stunningly hard to comprehend in terms of galaxies and light travel time. This is here, this is us, this is our little planet. This is what happens when numbers dance. Unlike the transit of Venus that went shooting straight across the sun, Mercury did this marvelous little dance, all because of the quirks of orbital positions, us and it, in relation to the sun. And that's why I have to keep drawing and painting this stuff. This is why I have to record things. This is why our entire species recorded things. And this is why the very first gods that mankind had was the moon and the sun. You can understand why. It's so majestic. And I also want to thank you very much for allowing me to share these images with you tonight. Thank you.
Why did you display it upside down?
Because that's the way it is in my telescope. You told me.
Good answer.
Yeah, thank you. Forgot to mention that, sorry.
Good evening. So yes, clouds did not collaborate, and 90%, this is what you could have seen through your telescope with filters, was rare moments when the sky would clear out. You could see a bit of that black dot, that was it, but was still enough time to take better pictures with I tried this with a Bader white light filter, and I used self-made filter. Andrew Brown, thank you for helping with manufacturing it. This little brown dot, as you clearly can see, it's Mercury sunspots. It was first time that I saw them with my own eyes, and I was surprised that actually they're pretty distinct, and they have this ridges around with different intensity. So you could see more details because there is enough light, even though during daytime there is still air oscillation. But and again, this image is also a composite of 5 to 10, I don't remember exactly, images of that kind superimposed into each other to reduce this oscillation. And again, close up of the sunspots, which is also kind of amazing. Just compare the size of them with the size of the planet, and it's amazing how big that event as such is when the sunspot is on the sun compared to the size of our Earth. These days, these weeks are very good for planetary observations. We have 3 big planets aligned. Well, Mars is not that big, but it's close, so it looks big. And today, or tonight rather, it's the opposition of Saturn. It's not as good as my previous takes on that in the winter, but this was, I think, worth of attention and worth of sharing. So I got pretty good. I believe it's a pretty good image of Cassini divisions all the way around. I'm happy with this image. And Mars, of course, being at the opposition, this was taken a week before the opposition on the 23rd. It's up to 10-minute video, and again, best frames were stacked. I was lucky to get some of the details. This is image that's turned upside down because of the rotation. And I wanted also to match those which are most widely shown when they show the Mars surface. They show it in that position. I was very happy and lucky and amazed and just in awe to see what Jupiter looks like in Florida. So this is a very specific location. Well, I guess it's only Ottawa that's a very specific location because we have so much air above our head streaming in different direction. There is a vortex of air moving back and forth and shimmering all the time, so that it's so difficult to get clear image of a planet. But in Florida, because of big, large body of water, it's much easier for air to take and to keep the stable temperature just a few meters or hundreds of meters above. So there is not much of oscillation going on. And again, when this picture was taken, it was below average seeing and way below average transparency. So I can't even imagine what it would be like if I happen to be if I happen to be in that area again and take a look during really good conditions. And just from last week, M13, it's also pretty high up these days. I wanted to share this image with you as well, because this is pretty amazing object. The longer you look at it, the more stars you see around, and the pictures sometimes can show a little bit of difference in between blue and red stars, or rather yellow stars. So it looked pretty impressive for me. I guess that's it. Thank you.
Paul, are you here? Oh, hey, come on down.
Okay. Hi, everybody. First, I just want to say to Roman and Chris, good job on that projector. That is such a huge improvement over what we had before. So good job. Anyway, Mercury transit. We were fortunate enough to catch some of that. There was 4 of us that were pulling our hair out, those that have hair. Trying to figure out where to go for this to get our best chance at getting clear skies there. So around midnight before the transit, Eric LeMay, Oscar Echeverry, James McQuaig, and myself headed out for Nirvana, the abandoned airstrip north of Bon Echo Park. We had been analyzing the satellite data all day and determined that that was probably our best chance of getting a spot where we get most of the transit cloud free, because everywhere else was looking pretty dismal. As it turned out, we really lucked out. We had, for about 99% of the event, we had clear skies there, the odd periodic thin cloud moving through, but nothing to block our view. So we were very fortunate that we were able to see it. So anyway, this is a high resolution view that I took of Mercury about 20 minutes after the ingress phase. It was about the most stable time of day for the air that we had. The seeing was atrocious that day, but the morning was better than the afternoon, and in the afternoon we were contending with winds. So May 9th, we were wearing parkas out there because the winds were at our backs, and it was actually quite cool. So that's a still image taken from a composite video. This was taken with a 6-inch Maksutov Cassegrain running at about 1800 millimeters. And that's with an X-Image 5 video camera. So I can show you the video that I used to get the frames to assemble this. Chris, if we can let the next video roll there. Yeah. So this is this is basically unprocessed stuff. About 20 minutes after ingress there, and you can see the seeing was bouncing around there as well. Plus, we did have some breezes in the morning there, but that was one of the best views that we had there. Like I said, it was clear all day, but as you'll see in one of the subsequent videos there, the conditions got a little hairier there. But it was cool to see. We got it right from ingress there all the way through to egress there, and so it was a very satisfying event. So I was using a couple of different cameras, a couple of different scopes, and the next image I have for you, this is a test I'm doing. This is a test. I've never done this before, and with the new projector, this is awesome. So some people can do this really easily, some people can't. This is a stereo pair. These images were taken about 25 minutes apart. Some people can merge these images really well and easily, and you'll see Mercury floating above just the right-hand edge. This is just before egress. If you can't, all you have to do is try to cross your eyes a little bit. And if you have a problem with that, I'm an old hand at this. When I was in university, I was one of the courses that I was doing was Earth Sciences, and we had to do a lot of aerial photography, stereo pairs on aerial photography. So I learned how to do this relatively easily, and I can usually merge most such images. If you're having problems with it, you can try this. You can try holding up your hand at about arm's length, hold up your index finger, and put the tip of the finger about there somewhere. And focus on your finger, and then just kind of let your gaze go up above the finger and see if you can get those to merge, and you'll see Mercury there floating 3D above the disk of Saturn. So, is anybody getting that? Yeah? Excellent! I was wondering whether, actually I'm going to have a look myself here on the screen. Wonderful. Okay, so for those of you that can't merge them and get the 3D effect, these are two images of Mercury taken about 20 minutes apart. So as you see, we had pretty good conditions there. The sunspots were visible, and Mercury was very, very cooperative there. So, okay, next one I have. This is again, this is just a video. This is the egress phase. I assembled this video from this is about the last 15 minutes of the event. I'll show you this is the full view I got through the telescope, and then I'll do a close-up of that. But you can see Mercury getting ready to exit stage right, as it were. Go ahead, Chris. And you can see the winds were really bouncing around the mount. But you can just see a bit of a black drop effect there too, as it leaves the edge of the disk. And literally, you see those clouds that move by? That was like 2 minutes after the end of egress there, so we really lucked out.
That was sped up, what, 10 times?
That's substantially sped up, yeah. That was 15 minutes shown in 15 seconds.
60 times.
Yeah, so 60 times, yeah. And if you can roll that last one there, Chris, this is a close-up at full resolution. Oh, yeah, of that egress there, so you can roll that one there too, Chris. I haven't had a chance to do an image stabilized version of this. Maybe I can do that for you next. Sure. Oh.
I was hoping to get the black drop. I could get it on home.
Yeah, you could see it in several frames there. I mean, part of it was the fact that the seeing was awful there, and it was really hard to get a very, very crisp focus in the afternoon there. But you can see, yeah, just starting there. So we had a good time there. We were out at Nirvana for 8 hours there, and let our cameras roll. While they were doing that, explored some of the environment around there. But yeah, it was a great place. Bugs weren't too bad because it was, like I said, we were wearing parkas with the wind. So we were very fortunate to have a good opportunity to see it.
What's the explanation for the red disc around your first picture?
That's a sort of a contrast effect. With the cameras, it's actually very common when you get a very, very dark object against a very, very light background there. You'll get some bleed in on that, but it's not a real artifact. It's not like Mercury all of a sudden got an atmosphere or anything like that. It's literally the high contrast region between the dark, very black spot and the background of the sun. Got that on the Venus transit too. Thank you.
Okay, great. So we've reached basically the end of the meeting. I'll try to zoom through the last couple of announcements as fast as I can. So we've had one public star party, and it was a great success, from what I understand. The star parties are free, and they're obviously for both members and the public. They're at the Carp Library. They're held at the Carp Library, which is adjacent to the Diefen Bunker. And so you can see that there's the observing site, there's the Carp Library, and the Diefen Bunker, and Carp Road. So we had it on our primary day, great. So that's good for Ottawa. And the next date is on June the 24th, and those are the rain days. This is Estelle's Pick of the Month. This is a new book. It's just been published by the RASC. It's called Building a Small Observatory, Lessons from Builders by Charles A. Enos. Oh, well, that didn't work. This is my Weird But True. This is Buzz Aldrin, who I think looks a bit like Chuck O'Dea. He was born on January 20th, 1930, and I'd just like to say that I was also born on January 20th, not 1930, but January 20th nonetheless. As you can see, Mr. Aldrin has some wonderful accomplishments. First one up on Gemini 12. He was the lunar module pilot for Apollo 11 and the second human to set foot on the moon. But there are two weird but true facts. The first is that his mother's maiden name was Moon. And he was also the first person to urinate on a celestial body. As he got to the bottom of the lunar lander, these are his words. I'm not making this up, and he says that himself, something just came over him, and he felt the need. I suppose when you gotta go, you gotta go. And as he got to the bottom of the lander, ladder, he just had a pee in his suit, which had a special contraption designed for that. And so that's one more first for mankind, I guess. No, yeah, number one. Number two and number one. Yeah, there we go. All right, so that's my weird but true fact for this month. Benefits of membership, as you can see, the costs down here. Regular membership $75, and if you're a student, $45. And there's also a family membership. You get, as a member, you get access to taking out books at the Stanmont Library. You get you can take out a telescope at the Ted Bean Lone Library, and you have access to the grounds, but not the scope, of the Fred Lossing Observatory. The Fred Lossing Observatory, the interior is accessed through a separate, with a separate fee. You also get these publications. These are the contact information. We've been streaming live. I got a message that Mike Mogadam was watching us on the train to Toronto. So, hello, Mike. Thanks for tuning in. And the older meetings are on YouTube, and this is where the library of previous meetings is. So today's audience was 119. Thank you to everyone who came, to you in the audience, and to those who took the time to make the wonderful presentations. And also, of course, thank you to our host, the museum, for allowing us to use this space. After meeting, as always, at Gracie's. Hope to see you down there. Next meeting, this is important. That should be 7:30, shouldn't it? There's always one slide we always screw up. Anyway, I take responsibility for this. I review it with Chris, and I missed it too. Next one, despite what it says on the slide, it'll be 7:30 p.m., but it will be July the 8th, which is the second Friday of the month. Of course, the previous Friday being Canada Day. And we will have a new background photo. All right, so thank you very much for joining us. Hope to see you next month. And we'll now, if you want to come on down, grab some tickets for the door prizes. We'll draw them in a matter of minutes. And as I said, we have the telescope will be a special prize for someone who doesn't have a telescope already. So thank you very much. Hope to see you next month.